Let's get going then. Good afternoon, everybody. Thank you so much for joining us for today's London Java community event. Let me introduce myself first of all. My name is Abby and I work with Barry Cranford, who's the founder of the LJC, and I have the privilege of hosting today's event with Olena. For those of you who don't know, the LJC is just one of around about 15 different tech communities that is run by RecWorks. We are a tech recruitment company with a huge difference. So as a company, RecWorks believe that recruitment really can be a force for good in the industry beyond just placing people in jobs. We have a particular focus on learning, mentoring, and personal development. If people want to learn and others want to teach, we are happy to connect you through our communities and events. We see this as giving back to those we've worked with in the past, but also paying it forward to those we hope to work with in the future. To date, we have run over 700 events for engineers and developers, students, graduates, and CTOs. We have run conferences, lightning talks, hackathons, all sorts. In January of this year, we made our 4,000th introduction through our Meet a Mentor program. We are really excited to make 5,000 introductions and to see where that community is going to go next. As I've already said, we love to give opportunities for people to connect, and this event is part of that. If you'd like to know more about any of our communities, please do get in touch with myself, Barry, or Helen Lewis if you know her, and we can take it from there. The recording of today's session will be available on YouTube, and I will put the link to our channel in the chat later on for you. During the talk today, if you think of any questions, please do feel free to put them in the chat and we can visit them after the talk, or just make a note and you can unmute and ask yourself if you're happy to. When Olena's finished her presentation, there will be time for Q&A at the end. So with no further ado, over to you, Olena.
Hello, everyone, and welcome to the session Apache Kafka Simply Explained. I'm Olena. I'm a developer advocate at Ivan, where we help engineers to deal with the complexities of database infrastructure. And at Ivan, we also contribute a lot to open source projects. That's why today, I would like to talk about Apache Kafka, an open source platform that you undoubtedly heard of. Unless you accidentally came here to learn more about Franz Kafka, then I must disappoint you, because today we will look into the distributed event streaming platform, which exists already for more than 10 years and became de facto standard for data streaming. It is widely used in the industry, but still somehow challenging to understand, especially when you begin to work with it. That's why our goal for today is to look at this technology and understand its fundamentals and building blocks in simple terms. This doesn't mean that we will not dive deep, but I'll try to keep it simple. So what is our plan for today? We'll start with a bit of background story to explain where the need for Apache Kafka is coming from. Then we'll dive into the theoretical background information to introduce you to the basic concepts of Apache Kafka and its fundamental building blocks. So some kind of a Lego stuff. We will mix different theoretical concepts with small practical exercises. And I have a GitHub repository prepared with exercise steps. So you can either follow along here and now if you are really good at multitasking, or you can take it home to experiment later, which might be a bit a better option. Finally, we'll look at a couple of more advanced topics, and we'll outline next steps you can take to start using Kafka for your projects. And before I give the definition for Apache Kafka, I wanted to give you an example of a project where Apache Kafka makes a significant difference to the users and to developers. And my ingenious project idea is based on an animation movie you might have seen, Zootopia. If you haven't seen it, doesn't really matter. But if you have, you'll recognize some of our characters. Because today, you and me, we are going to build the first e-commerce product of Zootopia, and we'll call it Shopitopia. Like in any e-commerce project, we want to have an inventory of products that we offer, some kind of a web interface to start with, where our lovely customers can search for products, select what they want, place an order, pay, and wait for delivery. And this is probably a minimal set of what we expect from the product. When starting to build it, during an MVP stage, maybe, we can choose to keep all our subsystems next to each other as a single monolith, where our front end and our back end communicate directly with each other. We probably have a data store for the products and for the users, and some backend modules for ordering, payments, and delivery. And it's all closely interconnected. And this might work at start when we still have small number of users and limited amount of functionality. However, when we start scaling, once we have more customers coming to our website and a wider variety of products, and once we decide to offer more services to our client, the modules and complexity will, of course, increase. And we probably replace our front-end web. We will have a separate interfaces for web, for Android, for iOS app, and for user convenience, we probably add some notification service, recommendation engine, tracking system to follow so that our customers can follow the parcel, how it is delivered to their houses. And if we continue adding all of them into this monolith, very quickly, the current architecture and the information flow will become a mess. A mess which is difficult to support and difficult to expand. And with our development team growing, hopefully, no single individual will be able to keep up with the data flow of our product. It will be as painful as untangling your headphones cable after a day in your pocket, if you are still using cable headphones. So at this moment, we will need to have a tough conversation how to split our monolith into a set of independent microservices with clear communication interfaces. What is even more crucial, our architecture must allow us to be as close to real-time communication as it is possible, to rely on the real-time events where users don't have to wait till tomorrow to get meaningful recommendation based on their latest activity. Nowadays, users, including us, expect immediate feedback based on their actions. We learn to be very impatient with waiting. And as engineers, we want to be able to get the maximum value of real-time data in the most efficient and hopefully painless way. So this is good for users, good for business, and good for us. Additionally, it would be also cool to have real-time monitoring, processing, and reporting for our system. And I think I named so many different things which we wish to have. Introducing such activity tracking is an immensely high volume operation. So it's quite a lot to ask, and the system should be resistant to failures, and we must prevent data loss. And especially with the growth of the user base and hopefully users' interest in our product, the amount of difficulty has a potential to grow exponentially. So, but luckily for us, these are exactly the challenges with which Apache Kafka can help us. Apache Kafka is really good at untangling data flows and simplifying the way we handle real-time data. So this is two cases where we can successfully use it, untangle data flows and simplify the way we handle real-time data. So now I would like to return to the definition of Apache Kafka. And I know how boring definitions can be, but it's also so important for us to be on the same page and understand what exactly we are talking about. So Apache Kafka is an event streaming platform that is distributed, scalable, high throughput, low latency, and has a very large ecosystem. Or simply put, it is a platform to handle transportation of messages across your multiple systems, multiple microservices, or any other working modules. Can be just a front-end app, as we showed before, but it can be a set of IoT devices or some backend modules. It can be a teapot in your kitchen sending information about the water temperature to your phone. Apache Kafka is distributed, meaning that it relies on multiple servers with data replicated over multiple locations, making sure that if some of the servers fail, we are still fine and our data is still complete. So our customers can continue using our product without any issues, even if some of the servers crash. Apache Kafka is also scalable, so that you can have as many of such servers as you need, and they can handle trillions of messages per day, ending up in petabytes of data persistently stored over disks. And the word persistently is very, very important here. And what is also awesome about Apache Kafka is its community and the wide ecosystem, including the client libraries available in different languages. And I must say that Java is the king there. And also there is a set of connectors to integrate with your existing external systems that you already use, so that you don't really need to reinvent the wheel to start using Apache Kafka, but can rely on the work of other amazing developers who run in those similar issues already and solve those. And we will see this in action a bit later. But to understand how Apache Kafka works and how we can work with Apache Kafka effectively, we need to talk about Kafka's way of thinking about data. The approach which Kafka takes is simple, but I think quite clever. Instead of working with data in the form of static objects or final facts, final information which is aggregated and stored in a database, Apache Kafka deals with entities described by continuously incoming events. What do I mean by that? So in our example, for the e-commerce project, we have a list of goods that we sell. Their availability and other characteristics we can store in a table in a database. So we can have information, how many donuts are available, how many ties we sold already, and what was the interest to the glasses, and so on. And this gives us some information, some final compressed results. In case we want to get more data about sell trends, demand, peak search times, we should have planned this in advance. Because now that we have the data, we cannot deduct this information from what is stored in the database, at least that compressed version of the data. Because anything that is stored in the database is a snapshot. It's kind of like one-dimensional view, or we can think as a single point on an infinite timeline. What if, instead, we view this data as a flow of events? For example, some customer ordered a tie. Another customer searched for a donut. Then we dispatched the tie to the first customer, and the second customer decided to buy a donut. And so on, we have events coming into our system. This shows us the whole life cycle of a product purchase. And instead of seeing a single data point, we observe the change of state. If we want, we can replay the events. We can start from the start. We can move to a given point of time. We can't change any of those events. They already happened. But we can relive the events again and again, calculating metrics we need and answering a variety of questions about products and sales. This picture, of course, looks way more complex than a table in a database, but instead of giving us flat final numbers, it gives us this 360 view on our data and plenty of possibilities so that we can answer all kinds of questions later in time. And we don't have to try to guess what questions we will have later in time. And by the way, this type of architecture is actually called event-driven architecture. And I believe many of you probably already familiar with that term. And let's look how Apache Kafka works with the event-driven architecture, how it works with the data feeds. So I have Apache Kafka cluster. I put it here in the middle. In this central area, we'll see what happens inside the cluster. And on the left and on the right, we will see how other applications, especially those you build, interact with the cluster. Apache Kafka cluster coordinates data movement and takes care of incoming messages. It uses a push-pull mechanism to work with the messages. And this means that on one side, we have structures that create and push messages into the cluster. They are called producers, and these are applications you write. On the other side, we have consumers, and consumers pull and read the messages and do whatever you need to do with that information. Again, these are the modules you write and control. And you can have as many producers and as many consumers as you need. And in our examples, the producer can be part of the front-end applications, web and mobile apps, observing user actions, packaging that information, and sending events to the cluster. And the consumers can be, in turn, connected to the subsystems responsible for notification, deliveries, and recommendations. Consumers are hardworking apps that read messages one by one, processing information that is needed. And here, in fact, producers and consumers can be written in different languages, different platforms, completely not knowing about each other. And this is how Apache Kafka helps decoupling our module. So in our case, decoupling our front-end applications from the delivery subsystem or other microservices. Because those modules, they don't know about each other. They only know about Kafka cluster and they communicate with the Kafka cluster. What is more, if you need, you can shut down some of the producers and add other producers that will be sending to events to the cluster and set. And the consumers will not care that the messages were produced by some other entity. They wouldn't even realize it. There is no synchronization expected between the work of producers and the work of consumers. And in this way, they work at their own pace and convenience. What's more, consumers can get broken and producers will continue working without issues. They will send the events to the cluster where the messages will be persistently stored. And when the consumer is restored, it can pick up where it left off. So in this way, the work can happen in an uninterrupted manner. So now that we know where the messages are coming from and who later reads them, we can look inside the Apache Kafka cluster. And let's zoom in and see what takes place with the records especially, and how the whole magic works. So a set of events that come one by one from some kind of source is called a topic. A topic is an abstract term, and we'll come back to this a bit later, but let's say it's not how stuff is stored on the disk, but rather how we think of it to simplify things. And you can have as many topics as you need. They can be compared to tables in databases. So this one can be product-related stuff, describing the cycle of product sales, what was searched, ordered, delivered. We can have also a topic related to new user registration and conversion, and maybe a topic related to application events, any errors, warnings, or current health state and messages on it. The data is continuously flowing into the topics, like water in the river. There is no pauses, no breaks. As long as our application is working, we have new users registering, products being purchased, so there is always some life happening there. The messages inside a topic are ordered. And each message has a sequence number, which is known as offset. This number uniquely identifies the position of the record, and it's quite important thing in Apache Kafka. Also, messages are immutable, so that you cannot really change any of the messages later. And when you think of it, this makes total sense. When some event happens, someone bought a donut. You can't really go back in time and change that fact unless you are Michael J. Fox and you have a DeLorean. But otherwise, if you really don't like the donut, you have to throw it away. But technically, that's a new event coming to the topic. Also, when looking at the topics, and if you have experience with working with queues, you might see a topic as a queue. But here is a twist. In Apache Kafka, unlike many other queue systems, the consumed messages are not removed from the queue and not destroyed. Instead, they can be read multiple times by multiple consumers when needed. And in fact, this is quite common scenario. Information from a topic will be used by multiple consuming applications for different needs, approaching data from different perspectives. Because as we said, when working with events, we have this 360 view on the data. And this is pretty cool that we can reuse stuff. And this is where the persistency in storage also plays a significant role. Now that we covered a bit about the topic, consumers, producers, I think it is time to learn how we can create those entities or those elements on our own. And again, I prepared a GitHub repository with the demo steps that you can follow, or like you can follow what I will be showing on your own now or later. Apart from code itself, you find here necessary dependencies and an example of an environment file where you need to put connection properties to your Apache Kafka cluster. There are also some instructions on where to get those properties. And yes, to run these examples, you'll need Apache Kafka cluster. I added links on how to set up the cluster manually. It is an open source product after all, and you can use its source code for it. You can also use Docker container or even Homebrew on Mac if you're using Mac to make it a bit more simple. or you can move one step further and use one of the available managed versions. I personally will be using Ivan for Apache Kafka, which is super intuitive and removes all complexity handling infrastructure for such a complex project. But for all transparency, I work for Ivan, even though it actually also helps me to know how much love our team puts into Ivan for Apache Kafka. That's why I can only recommend it. If you want to try it yourself, don't hesitate. There is a free trial, which will be more than enough for what I will be showing today. And you don't need to provide a credit card or anything else. So registration is super, super fast. So feel free to use it if you like. And once you have the cluster running, you are ready to create a topic. So in these demos, we will focus on a single topic. The topic will contain events based on the activity of our fluffy customers, searching and buying products in the online shop. And we'll create a very simple producer and send records into the cluster. And then we will create a very simple consumer and retrieve those records, read those records from the cluster. Producers and consumers can be located anywhere on the internet. So the first step in building each of them is to configure proper access to the cluster. And this means that we need to specify the address of the server and also the serialization mechanism, so in which form the data will be transmitted. Next, we need to make sure that our cluster can trust our producers and our consumers. And for this, I am using SSL mechanism as a default one, and more instructions you will find in the GitHub repository. And we here specify where to find our trust store and key store and define all that stuff. And once it is done, once we have this kind of link between our cluster and the producers and the consumers, we are ready to write the producer itself, the producer code. So for this, I'm relying on the Java library for Apache Kafka. And with its help, I'm creating a producer object. And also, I specify the name of my topic so that we will use it later. Then I create a message. I'm using here just a JSON object. So I generate some kind of message. It doesn't have to be JSON. I selected it, but it can be a string. It can be something else. Then we package that object, that message within the record. And finally, we send the record into the cluster. And these are just the steps which are needed for one item to be sent to the cluster. But for this demo, of course, I wanted to have something a bit more continuous, which will send many messages non-stop into the cluster. So I used a good old friend while true loop and added a second of delay at the end of the cycle. So now if you run this code, it will be sending many messages one by one. And looking at it, you also might wonder, what do I have in the generate message method? Over here, I just create a very simple JSON object with just 3 properties: which customer does which operation and on which project. So customer, product, and operation. And then I have predefined stuff, and I just randomly select those properties. And then we have the message, and we are sending that message to Apache Kafka cluster. Next, if we run our simple producer, which you can find in the repository, you'll see that we send those short messages into the cluster, and we output what we send. But you don't have to trust me to verify that they indeed land into Apache Kafka cluster, we can use our consumer to retrieve and read those messages. To create a consumer, again, I'm using Apache Kafka library. We create a consumer object and we subscribe that object to the topic, the same topic where we were sending data just right now. And then once it's done, we are polling for the data for new records on a regular interval. And if there is something, then we output that information. And if you start the simple consumer, which you can find next to the simple producer, you can see that first what we do, we connect to the cluster with the help of the SSL mechanisms which we provided. And then we start pulling the messages from the cluster, the same messages which we sent there. And this is the basics of a simple producer and consumer written in Java. So now that you are introduced with the concept of the topic, let's add two other interesting concepts: brokers and partitions. I already mentioned that Apache Kafka cluster consists of multiple servers, and these servers in Apache Kafka world are called brokers. And topics are supposed to be stored on the servers on the brokers. And those topics, as you could guess, they can be quite big. They can have millions and possibly trillions of events which we store, and we store the data persistently. So we need to figure out a good way how we are going to store those huge topics on the servers. And this is the moment where, if you remember, I mentioned that the topic is not an abstract term. So yes, so the topic itself is not a physical, tangible thing stored as a whole on a single server. It's probably neither reasonable nor feasible to keep a topic as a single piece of data on a single machine. Very probable that one day the size of the topic will outgrow the server's memory. So we need a good way to scale this data horizontally and not vertically. And to achieve this, or in Apache Kafka, we are dividing the data into chunks, into multiple chunks that then are stored across multiple machines. And these chunks we call partitions. Each of the partitions is technically a log of messages. And some of you might be familiar with the concept of a log, but if you're not, it's pretty simple type of storage, append only, sequence of records ordered by time. So these logs, or we will be calling them partitions, are stored on the brokers on the disk storage. Partitions are independent, self-sufficient entities, and each partition will maintain the sequence number for their own values. Remember those offsets I mentioned before. So the offsets have only meaning within partitions. And this means that the numbering of items right now on the slide is totally incorrect. Instead, each partition will have their own count, and let's fix it. So now every partition has 1, 2, 3 messages and so on. So when in the past I was saying that producer writes to a topic, what I meant is that producer writes into a set of partitions and the consumer reads from the set of partitions. And behind the scenes, our consumers and producers know how to work with multiple partitions. However, there is still some challenge which we have to solve here. And the spoiler alert, the challenge is related to the order of the messages. Because in some cases, we need to have the same ordering of messages read by the consumer as it was sent by the producer. And to understand what is happening, let's look at this use case where we have the scenario where we have a sequence of messages and we have 3 partitions. In the most simple scenario, by default, the items will be distributed across the 3 partitions in a way where we cannot predict which message will get into which partition. Apache Kafka will make sure to distribute them efficiently, but we cannot predict how. And if you think how information will be read by the consumers from these partitions, you can also notice a tricky part, because the consumers also will read in some order which we cannot really predict. And this means that the order can change from the moment when we push the messages into Apache Kafka cluster till the moment we read it from Apache Kafka cluster. And for distributed system, this is totally normal. However, of course, we have our own scenarios, our own flows, which we need to solve. And sometimes we do need to have a proper ordering of messages. And Apache Kafka, they don't guarantee how the messages will be distributed across partitions, but they guarantee, what they guarantee is the order within which the single partition holds the messages. And we need to use this information to our advantage in those cases where the ordering is important. For us, for example, the ordering of messages related to a single customer is quite important. So logical sequence of events that the customer first will add an item into the basket, then does a payment, and then the delivery follows. That should be in place. If the ordering of those events for a single customer is messed up, our system becomes unreliable and honestly quite useless. And to guarantee that the ordering for every single customer is correct, we will split the messages across partitions in a way that the data related to each customer will get exactly into the same partition. And we can do it with the help of a key. So far, our messages consisted of some message body, but we can also add a key for every message. And the key plays a dramatic role in how messages are distributed across partitions, because all messages with the same key will be added to the same partition. So here we have a scenario where we have a topic with product purchase lifecycle, and we have some actions performed by our customer folks as well as other customers. And we set the key to each message to equal to the customer ID. So the customer who made that action, and the body of the message itself is a customer action. And the first message with key equal to Fox will be sent to the partition number 1. And this is an indication to Apache Kafka that all following messages with the same key must go into the same partition. And same for other customers. So for the piggy, it will be partition number 2, for the rabbit, the last partition, and so on. All the data will be divided across partitions. And now when we need to read the data, we can be quite sure that all the messages related to customer folks will be in one partition. So when consumers will read those messages one by one, they will be in correct order always. The order between customers is not really relevant to our use case. That's why we don't care about it. But when it comes to a specific customers, the order will be remained. And we can see this in more details in demo. Over here in the consumer, I would like to add one change. I would like to just add information about the partitions to print out the partition information and the offset of the messages. And if we run now our consumer without any other changes, just that printing out change for the partition. And if you pay attention to this log, you can see that the messages to the same customer is coming from different partitions. So here it's like a salad. Everything is mixed. So this is default behavior where Apache Kafka distributed as evenly as possible our messages across all partitions. I also added another type of the consumer. It's called the filtered consumer here. There are only messages related to Judy Hopps, so that it's easier to see that the same customer has messages from different partitions. So here it's from partition 1, 0, and 2. So all is mixed as expected. But to fix this, we can add the key. So now we need to make changes in the producer. So we will evolve our producer by adding to the record the key information. Key here for me is a customer ID, or actually it's customer name for my very small project. But this is something identifying for the grouping of the messages for you. And then we send the key, the value, the topic name into within the record into the cluster. And now if I will run this change producer and then I run the changed consumer, we can see that the messages related to the activity of Nick Wilde always come from partition 0, whereas the messages from our Mayor Lionheart comes from partition 1, and so on. So there is a consistency between which partition the messages will get and the ID of the customer. And this is even better to see with Judy Hopps, with the filtered consumer, where we can see that all messages are always getting to the single partition, to the partition number 1. Okay, so we talked about topics and that they are divided into partitions and spread across the brokers. But our story won't be complete if we don't talk about replications. And replications are immensely important. Hardware can fail, there can be a power outage. We need a way to ensure that if any of such undesirable events happen, our users won't notice a thing. They can successfully do whatever they are doing, even though one of our servers is down. And let's see how the replication works in Apache Kafka. Let's come back to this picture where we will talking about our topic and how it is distributed across multiple partitions. Dividing big topic into these digestible chunks gives us also an elegant way to replicate the data. And to achieve the replication, each of the brokers will hold not only one, but several partitions. So here, in our case, every broker will have 2 copies of different partitions. By the way, because it's 2, we call it replication factor of 2. In many cases, the recommended would be replication factor of 3, and you can imagine how our system will look if it will be 3. Replication, of course, raises some new questions. And first of all, maybe something you already thought of. Which partition, which broker do we write into, and which one do we read from? And a short and a bit overly simplified answer is that we write and read from leader replica. A single replica. Leader replica is always the one we write and read from. Whereas the other replicas are followers, and will copy data from the leader. And this involves things like leader election and re-election when needed, but those technical details are for a different story. Another interesting question is what happens when the server crashes, when one of those servers crashes. What happens to the data that producer is sending there? Or is like producer continues sending there, not knowing about that? Even assuming that the server will be recovered, another replica will probably be become a leader. This takes time, and a producer, as we said, never stops working. And there are several options we have here, and they are based on the type of data we are sending. And there are actually like 3 scenarios, which, depending on which, you can treat different failures in 3 different ways. So scenario number 1, if we have a topic dedicated for some data where we can lose some part of it, for example, if we have this delivery system and our vehicles, which are bringing the parcel, sending us notification about their location, and if the partition or the broker goes down and the information is not stored there, we can still approximate the location of the vehicle based on some other data points. So it's not a big deal, and it can be totally fine if some portion of this data is lost. In this case, we can use, we actually say that we don't require any acknowledgement. So here we set this X to 0. However, of course, this will not work for all the cases, because, for example, for our topics, losing data is not something which we want to have. So we can request producer to send the partition to send the information that the information was received by the leader partition. And in this case, we will minimize majority of data loss. However, still some data loss is possible, and it can happen if the leader partition the leader replica will send us confirmation, and after it sent confirmation, it crashes before giving a possibility for the follower replicas to get the data. So in this case, producer will receive success message confirming that everything is good, but in fact we lost the data. And for this case, we can ask for confirmation not only from the leader replica, but also from all other follower replicas. And in this case, we will not have any data loss at all. However, this of course comes with a price for extra rounds of information, and we need to make a decision if that is worth for our use case. I think the middle option is the one which is most commonly used, but in case you don't need confirmations at all, you can use the first option. We covered a lot of Kafka fundamental blocks, and we focused on the topics, partitions and replications, but I wanted to talk very briefly about one practicality of working with Apache Kafka, and to share with you a concept which is a bit more advanced, but also that can significantly simplify your development when you are using Apache Kafka. What if I told you that instead of writing your own consumers, your own producers, and testing them, finding all corner cases, filling bugs, and so on, you can reuse the code already written before you? As I said, Apache Kafka exists for many years. That means that many people before you already asked the question how to load information from Kafka to PostgreSQL, or how to load information from another stream sources, how to source data from Twitter feed to Apache Kafka. And already some years ago, Apache Kafka introduced Kafka Connect, technology which does exactly that. And you can write either your own connectors, or you can reuse some open source connectors and use them instead of the producers and consumers. And to share with you a very small example, how to load data, or speaking in Kafka language, how we can sync the data from Kafka to OpenSearch. And I have already OpenSearch cluster, and on the side of Kafka Connect, we need to create a configuration file, which looks like this for our case. And Kafka Connect will use this configuration file to establish connection between Kafka topic and OpenSearch cluster. And then we can use this, we can wait till the data is flowing into OpenSearch cluster. And here I'm using the dashboards to see those things. And I think we are slowly running out of time. We covered plenty of things. And I wanted to leave you with some ideas what you can check or you can do next to start using Apache Kafka for your project. So first of all, it really makes sense to practice fundamentals or play with producers, consumers, and other things which we covered. Next, if you don't like to write your own producer or consumer, you can use a KiCad tool. This is a command line tool, which is super nice because you can send messages to Kafka cluster directly through the terminal and then read those messages in a separate tab in the terminal. So it's very easy to use, and then you can observe what is happening with partitions and so on. Then we were using JSON objects, and JSON objects are great at sending data, but of course, when you have a bigger project, you probably want to align on what structure, on schema of the data you are sending to the cluster and what you are expecting to receive. So you need some kind of a schema registry, different options available, so look at them as well. Also check what kind of connectors you will need and if there are already available options which you can use or maybe build on top of those. There are plenty of open source connectors available. And also check the Kafka streams because they are super amazing for the real-time data processing. I left these and other links in the same GitHub repository, which I mentioned like probably already 10 times. So you can check those there. And lastly, if you want to try Apache Kafka, check out ivan.io. This is a website of the company where I work, and we offer the fully managed version of Apache Kafka and other database solutions. You will have a free trial for months, so you can create a playground and experiment. So check it out, let me know how it goes, and thank you for being at the session. I am all ears to your questions.
Thank you so much, Elena. That was fascinating. I love it. I always love hearing everybody who speaks to us. There's always something to learn, and that's brilliant. Before I forget, if anybody does want the recording of today's talk, you can get it from the LJC YouTube channel, which I've just put in the chat, or ping me a message on LinkedIn and I will make sure you get the video. I will be posting it as well once it's ready. So hopefully you will get hold of it. We do have a couple of questions for you, Elena. So forgive me if I pronounce anything incorrectly, but I will do my best. What are the main differences between a Kafka architecture and what was previously fashionable? So, for example, enterprise service bus products.
To be honest, I cannot really answer. Probably, I'm not sure. I never worked with enterprise service bus. So, but my guess, for example, how I mentioned that the queue, like the difference between how Apache Kafka treats the messages and other queue systems. In the queue, we often read the message, we take it and we remove it. So it's only like it's going there and you take and remove it. Whereas in Apache Kafka, the data is persistently stored till some condition. So you can actually like expire the messages, but you don't really like remove it when reading. And that can be the difference. Even though I also sometimes read and sometimes Kafka is kind of like mentioned like a bus. So who knows? I'm not really sure about this one. Maybe there is no difference, but I'll check it for later.
Yeah, great. Okay. So another question that's come through, why do we need partitions? Could we use many queues with different topics?
I think it depends on amount of data you have. So technically, you can have a topic which will have only one partition, I think, but I don't like, usually we use Apache Kafka for the scenarios where we have huge amounts of data going through the cluster. If you have only one topic, first of all, it's kind of like the replication would involve copying the complete object. So can your server handle that? If you don't have that much data and you still need to use the functionality of Apache Kafka, maybe that would work. But normally I would say that you want to divide it into multiple partitions so that it works faster. Also, that the replication parts are not as big and yeah, so that they can easily fit on the server's memory. Yeah.
Okay, brilliant. Another question, we've had quite a few come through alongside lots of comments that say thank you so much, this has been really interesting, I've really loved hearing it. So I'm skipping all of those, but you can see them hopefully for yourself. So we've had a question, how is order guaranteed across consumers? Should there be a single consumer for each partition?
So if you have a consumer and you have multiple partitions, the order is guaranteed in the way that consumer will remember the last message which is read for this by this consumer. So for example, even if consumer breaks, it remembers the offset of the last message it read. So when it recovers, it continues reading from there. So in this way, because it also reads messages one by one, like from the earliest to latest in the topic, that's why the order, it just cannot be different. It's always the same. So we put the messages there, like 1, 2, 3, 4, 5, and then it reads one by one. And if it breaks, like if something happens to consumer, then it goes away, but it remembers the offset. So you can have multiple, so we have consumer groups and they will actually work together in collaboration. But technically, I think that offset is the key to this, to kind of the order, so that there is no miscommunication between the consumers.
Okay. Are there any comparable products to Apache Kafka, and how do they compare?
That's a very tricky question, and I think that's actually a good one maybe for another visit here to talk. There are plenty. I think that there are a lot of competitors to Apache Kafka. Apache Kafka, of course, it's an open source product. So in a way, it's special because it's a very solid technology used for many, many years. So I think this is where it's the community itself, because like there is a lot of stuff which already like people run into the same questions and solved and expanded the whole ecosystem. So I think this is where the Apache Kafka stands out comparing to other comparable solutions by AWS or some others. I am not the biggest specialist to talk about others. I'm more like enthusiast about Apache Kafka. I think it's a really great topic to dive deeper for another time.
Excellent. We've had another question as well. Is there a downside, or have you experienced any issues with Apache Kafka, and how did they get resolved? I guess, as well.
So I think that with Apache Kafka, its power is also kind of not really a downside, but a tricky thing, because it's a very complex project. And so what we cover today is just the basic building blocks. But then, for example, how exactly you create the architecture for your product to send those messages. For example, we have that customer ID, right? And we divide it into partitions. But how to make sure that you don't really have one of the topics, or one of the partitions growing enormously, while others remain in small ones. So you need to think of it in advance, because like reshuffling data across partitions later is very difficult, because of course, like the ordering is so immense, and then if you want to reshuffle, you need like to read all the data. So this kind of investment into proper architecture is very important, and I think this is kind of rebalancing, like, yeah, so having partitions of different size and then kind of making sure that they are more or less the same. This is a very big challenge as far as I'm aware, with different approaches, but the most important one is to plan the architecture in advance correctly. But of course, you cannot predict the future. So
there's only so much planning you can do in that sense, I guess. But that's brilliant. So one final question, and then I will let you all lovely people go. That's been submitted is, how do you bridge a, generally speaking, synchronous web-based call with the asynchronous nature of Kafka? How do you make those two work together? Can you make those two work together?
That's a very good question. I'm just wondering, like, is it like the web calls, are they really like in a way when the activity is done by the customers, or like by some users of the website? Is it really like synchronous? I mean, does it have to be synchronous when we send the messages? Maybe I don't hear, maybe I need to think a bit deeper about this question, but I feel that actually the power of Apache Kafka to make it kind of asynchronous introduces more possibilities to the web side of things, because you're not really stuck with this synchronous fragility, like that stuff can break if something doesn't happen synchronously. You're more like relying on asynchronous events. Of course, you need also to make sure, like, this may be the challenge, is how on the website you are making sure that you are working with asynchronous events. I need to think more about it. This is a very interesting question, and I'm actually a front-end engineer for some past time, so I'll think of it.
Yeah, brilliant. Thank you. We'll have you back just to answer these questions. It'll be fun. We'll do a Q&A. That would be great. Yeah, so all that is left for me to say then is thank you so much, Elena, for your time and sharing what you know with us. We really appreciate it when anyone comes to speak to the LJC, so thank you for that. And thank you everybody who's joined us today. Really great to see you, and we look forward to seeing you at our next LJC event. Keep your eyes open and you'll see when they're happening. Thank you so much. We've got so many comments saying thank you, thank you, thank you, thank you, thank you. So brilliant. Thank you all for your time. Enjoy the rest of your day and have a great weekend, everyone. Thank you. Take care. Bye.